Alright, so we've pulled one of our 80 amp hour batteries out of its case, so you can see it here. And we're going to do some experiments now where we're going to deliberately short circuit a cell or two or three. We'll see how we get on with the test. And first of all, see what happens when a cell goes completely short circuit. And we connect it to it live through the BMS, so we'll be able to watch and see if there's any impact on the voltages here. So by putting a nail straight through the sidewall of these cells, the anode and cathode is no longer separated by the separator, okay? So these are going to be completely dead short-circuited. When the anode and cathode collide like that, it creates a lot of heat, and these cells are going to want to degas. Okay, so we're basically deliberately destroying these cells, putting under complete stress. And we're going to show you what actually happens live here on camera. So we got some nails here. Okay, so that's going to start shorting out, and that's going to want to degas. Okay, that is really in there. That's completely going through the cell. And just starting to gas up there now. I'm going to see if there's any. So voltage is all looking good so far. So that's creating a lot of heat, a lot of pressure. I can feel that cell getting super hot already. So lithium cells run a fire retardant electrode, so they are very safe. They won't combust. So lithium iron phosphate doesn't combust. It will go to thermal runaway. It's getting really super hot right now. Basically that cell is now in a short circuit condition. Okay, so let's put a load on this battery pack now. So we're going to turn the inverter back on. I've refilled this pot of water, and let's put a massive load on this battery now, and let's boil this, let this start boiling. Okay, if you look at the battery management system data for our app, you can see all 4 cells very happy, still maintaining a 12.5 volt voltage output at 180 amps load. So we've got a massive load on these cells now. That cell is ridiculously hot. They will be over 100 degrees Celsius now. And that battery pack is perfectly functioning with a completely destroyed cell. Okay, so let's turn that load off and let's destroy another cell. And this is the thing, if, you know, prismatic versus cylindrical. I mean, we exclusively use cylindrical cells and have been since our company started. And you know, one of the reasons is safety. I mean, that's a cell that's completely deliberately mechanically destroyed now and short-circuiting, getting very hot. And you can see it hasn't even started to degas yet, because this cell chemistry is very stable. And it can take a lot of abuse. So we're going to put another nail through cell next to it. Okay, and you see it's just starting to smoke now. If you zoom in, on a good camera, you will probably see just starting to ooze and just starting to smoke out now, right? And you can still, we're still maintaining perfect voltage on the battery pack itself. Okay, so you can see the chemicals are now colliding. The anode and cathode are starting to collide, creating a lot of energy. These cells are valved, so the valve will open and it will release release all the electrode if it needs to. Okay, but if you lose a cell on a prismatic cell pack, you've lost that whole battery pack, because there's only one cell or two cells per string. You can see here we've destroyed this cell, we've got perfect voltage, and that battery pack's happily operating. Okay, that still hasn't degassed, it's still keeping together. It's oozing out electrode now, you can see the electrode coming out, but it's not going to catch fire and it is very stable. So I'm going to try to get another nail in here into another one of these cells, see if we can cause a bit more damage. Okay, that one's come in at a tighter angle. Okay, that's quite violent there. Hey, whoop, there she goes. So that just degassed, because that was quite a violent. Yep, so that's clearly degassing, you can see that now. And that's oozing out. Oozing out electrode. And still maintaining voltage. So you can see there's no fire. The electrode's coming out. It's a very controlled process, and you can see the electrode's leaked, but it's not cross-contaminating to the other cells. This mechanical failure now is confined to one cell. It's a beautiful thing, why these cells are so safe. Why this mechanical, battery pack design is so safe, because if this was a prismatic cell, game over. There'll be a lot of energy coming out. Now with this design, you can see that that electrode, I mean, we're on a timber top table, and I'll be able to wipe that electrode down because it's virtually doing nothing. Okay, so that electrode, that just wipes straight off. Okay, hasn't burnt a hole through a wooden table. That battery pack is still functioning. So we've got two short-circuited cells now, and you can see they just, that one oozed its electrode and degassed very quickly. And we can still got 3.34 volts on every single cell pack. So that one's still very hot. And that one, yeah, they're both really, really hot. So there's still the chemical reactions carrying on there because they are completely destroyed. So still got a little bit of gas oozing out. Let's put it back on load again. So let's go to nice big 180 amp fat load again. Okay. So still got perfect voltage across all four cells, 12.5 volts. We've destroyed a cell on two different strings. So that's cell 1, that's cell 4. No issues. you've got a functioning battery pack. So if you're in a very remote location and you have a mechanical failure and a cell lets go like this, as explained in previous videos, this has no effect on the operation of the battery pack. Okay, so we're still running 176 amps, perfect voltage in all 4 cells, while these things are smoking out, degassing and oozing electrode. Okay, and that's a big thing, and a massive mechanical advantage of cylindrical cells, and why our battery packs are manufactured in this way. So yeah, there's your real life proof as to why we design batteries in this manner. So we've still got perfect voltage, running big fat loads, and you can still see smoke coming out of those cells. This battery pack, eventually all the chemistry inside these cells will keep will be in a short circuit state, will keep degassing to the point where there's no energy left, and they will essentially be isolated in that string. Okay, so this battery pack can still function for several years, okay, missing 1 or 2 or 3 or 4 or 5 cells, and it's going to provide service for a long time. So, you know, think about situations where you're depending on storage and power and battery power, and something like this happens to a cell, you won't know because it's internal, but your battery pack will still function for, you know, worst case several weeks or several months. So it is a real good advantage, and you can see how safe this chemistry in lithium iron phosphate really is. Okay, so what we might do next is, and you can see now, putting under massive load, it's just the electrodes coming out of those 2 cells, and it's just not affecting in the rest of the battery pack. The next test we're going to do the same test on a prismatic cell, okay, and we're going to see what happens. So we'll get this ready and we'll do on the next one. That cell there is already degassed, nothing else coming out of that one. This one's still hot, hasn't popped properly yet. Oh, that's all the way in there now. Should just pop. Oh, there it goes. Yeah, so that's degassed. Pop. And now we'll cool down because it was just so freaking hot. All right, so the 2 nails are still in these 2 cells over here. Battery pack still connected, still running, still functioning. It's been about half an hour now. No change in voltage. Battery pack still runs, can supply its full power. These cells have now completely cooled down because they've degassed, and that's it, they're isolated. So that battery pack will run for several years now. Next experiment we're going to do is, we've got a prismatic cell here. So I'm just going to show you the voltage of this one. So it's a brand new cell, we just bought it, 3.343. So she's nice and healthy. And this cell we bought on eBay. This kind of stuff you'll find all over eBay and Alibaba. This particular cell is a GFB, obviously 3.2 volt lithium iron phosphate, 280 amp hour battery cell. The person we bought it on eBay obviously doesn't even provide warranty for these sort of cells, so obviously B grade, you can't buy A grade cells on Alibaba or eBay, so plenty of this stuff out there. So same thing, we're going to put a nail through it. So 280 amp hours of energy compared to around 3 amp hours on these 2 that we've degassed and have cooled down, and that's it. They haven't affected any of the other cells. And we're going to see what happens. Okay, got some good penetration there. Let's see what happens. So anode and cathode will be short-circuited now, because that nail would have gone straight through the separator. You can start to see it slowly deforming. Corner of the cell pack slowly deforming, and it's going to be increasing in heat. Okay, recording all right. Oh yeah, it's just started oozing electrode. Yeah, it's oozing out now, so it's pressurizing. I'll just check the temperature as well to see how it's getting on. Oh yeah, the whole thing's getting hot now. Oh yeah, it's definitely climbing. Here she goes. There we go, that's what we wanted. Okay, so we put a big hex screw through the prismatic cell. There she goes. She's about to degas quite violently. Whoops. Oh, yeah. See, look at that amount of energy. Jesus Christ, actually exploded and caught fire, man. Get footage of that. Crazy. So there you go, guys. I'm gonna get a fire extinguisher and put it out, eh? But that'll take several hours. Well, there you go, mate. There's your proof. That's why Cylindrical is so safe. This thing just literally exploded, plus it's supposed to be fire retardant, and this thing's on fire. Lesson to be learned: if you're playing with this stuff, you're buying whatever unknown brand products off eBay and Alibaba and whatnot, this is what happens. There is no way this grade of cell is ever installed inside the EV market, inside an electric vehicle battery pack, because look at how violently this thing is on fire. I have to move that table out of the way, so it's probably going to start cooking my table. And that amount of energy in one cell, that's going to take hours to extinguish. Look at it. Look at that amount of energy. And that battery pack wasn't even fully charged. It was sitting like at 50–60%. It wasn't even charged. All right, guys. So, yeah, it's been a fun day out here. We've done a lot of cool tests and seen some really cool results. And you know, to finish up and tie everything up today, we've still got our 80 amp hour battery here operational. You can see the nails in those cells. Perfect voltage. I've just fired up this 3000 watt inverter. We got a frying pan here, getting up to temperature, and we're going to cook off this battery pack another 10 sausages, because it's still working and it's still powering induction. And this battery pack will still last several years. So you can see, guys, as a technology company designing and developing battery management systems, I think we make it pretty obvious that we do design and produce some pretty cool battery packs to go with it and support our BMS technology. Saying that I was going to cook a couple of snags before to wind up for the day, and that's exactly what we're doing.
Trying to prove that it, still works if that's this battery.
All it is coming off these battery cells. There ain't no trick photography here. Ain't no smoke and mirrors. So as always, guys, I hope you learned something, and we spent all day here, show some things and clarify a few concerns that a lot of consumers have as they do their shop around for which battery they're going to spend their hard-earned money on. And we're always here to back our product and do these videos to educate you guys and show you, the advantages or the real data and the real world information that you're always going to be asking when you're doing your research. So I hope today clarifies a few questions. Thanks for watching our videos as always, guys, and safe travels, and until next time.